Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about a process control block. What are the information that is stored inside the process control block and how was context switching done on the process control block. Process control block or task control block can access the information about a specific period or processes. This information included as follows. The first one is the process number. Process number is the number to address the process in the main memory. So as we are designing the PCB, we can design it along to this. So the first one is the process number. The next one is the process state. The process state can be any of the new, ready, running, waiting or halted or terminated state. So we include the process state in the PCB. The next one is the program counter. The program counter contains the address of the next instruction that is to be executed on this process. The next one is the CPU registers. Now the CPU registers may vary in size and type. They can include the index registers, the instruction registers, the stack pointers, general purpose registers, or any condition code information. Now, along with the program counter, this status information must be saved in the PCB so that it can be loaded in resuming operation of the CPU process and correctly afterward consuming the processes. So we will include the CPU registers in the PCB. The next one is the memory management information. This information includes the address of the base register, the limit register, the page table and the segmentation table depending on the memory system which you are using in the operating system. This information includes the address of the base register, the limit register, the page table and the segment table which we are using in the operating system's memory system. The next one is the accounting information. Here we will store that how much CPU and real time is used by the user, the time limit, the account number, the jobs of the process number and etc. The next one is the CPU scheduling information. This information includes process priority pointed to the schedulers and any other scheduling parameters that are need to schedule the processes into the job queue or in a CPU short-term scheduler. The last one is the I/O device information. Here the information about all the allowable I/O devices to the processes and the list of open files is informed. So this is a basic structure of a PCB in which the header contains the process number and the tailor contains the I/O devices and list of open files information. Now we will see that how the PCB is implemented as a repository to the processes and specific information about the processes is used when context switching is done. Suppose there are two processes, number one process is P0 and number two process is P1. So there are two more PCBs like PCB is for process P0 is PCB0 and PCB is for process 1 is PCB1. So while suppose the P0 is executing, then the PCB0 loads the set and PCB1 the current state is saving. So the PCB0 here loads the all information about these processes and PCB1 saves the current information about the process that is being executed. . Now when again the P1 wants to execute, then the PCB1 must load the state and the PCB0 must save the state. Here the P0 process is idle, that is why we are saving the process state of PCB0 and we are loading the process state of PCB1 to execute P1 in the current CPU. In this way, PCB can be accommodated to the processes to act as a repository to give specific information and context about the current process and the process that were being executed in the CPU. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.